According to the World Health Organization, it is estimated that the number of people with visual disabilities is 253 million. The cataract it is an opacity of the natural lens of the eye, which is located behind the iris and pupil. The main causes of blindness are cataract is an operate with a 25%, age-related macular degeneration with a 4%, and diverted retinopathy with a 1%. In Colombia, blindness and visual disability are health problems to which the population is vulnerable by age, diseases that cause visual impairments, and refractive errors, because there is an early diagnosis of the disease, or according to the percentage of tissue affected.
For the database, we search for image of healthy eye, an eye with cataracts in the page Kegel. In this page, we download a folder with normal eyes and a folder with eye with cataracts. For the processing, we use RGB plane. In our case, only use blue plane because highlights the main characteristics of our image. Then for the classification of the image, we use a probabilistic neural networks. These were in two layers. The first layer computes the distance from the input vector to the trained input vector with the purpose of identify how far or near are they between them. The second layer sums this contribution for each class to finally produce as a net output a vector. Finally, a transfer function picks the maximum of these probabilities and produces a 1 for that class and a 0 for the other classes. The process loads the image and asks the size of this. If it's 1632 for 2464, we perform the network process. If not, we apply the function imcrop and then does the normal process. Then go to the read the new vector and determine if it's a healthy eye image or no. We use the function uncrop because our neural network was based on characteristics of area and perimeter. So it was essential that our image have the same size so that it would be easier to detect the area of a healthy eye and eye with cataracts.
The guide consists of load database. It is a button which loads the folder of our training image. The layer button makes our neural network train. The load and save button allows us to choose an image from the specific database to know if it has cataracts or not and to save them. And the load button of the test part allows us to choose any image for our neural network to classify. When we perform these procedures, the original image and the filtered image will be shown.
Finally, when you load the new image, you can find a message with a eye with cataract or a healthy eye. The difference of this result you can see in the image process because when you have an eye with cataracts, you find a white circle in the image process. But if you have a healthy eye, the image process only show you a black circle.
Our conclusions are the preprocessing of the images. It is essential to work with algorithms in machine learning. Since the more improvements are applied correctly to the images, the better the image selection process will be. An effective and cost-effective tool is obtained for the early diagnosis of cataracts in the vulnerable population. However, the neural network had a percentage of error signs when filtering the images, and constant was applied that was in a specific range, so that in some images with cataracts A's, it didn't find its error well and classified them as healthy A's. We leave the constant with that range because it works with most of the images of AIDS with cataracts.